Hello students, welcome to Vyas Edification Kota. In this session of NCERT discussion, we'll be discussing chapter number 3 of NCERT class 11th mathematics, and today is the turn of exercise 3.3. That's what we are discussing over here. So let's continue with the first question without wasting any further time. What does the question say? Prove that sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4 is equal to minus 1 by 2. The question says prove that this is equal to this. For proving, what do we need to know? We need to know the value of sine pi by 6, we need to know the value of cos pi by 3 and tan pi by 4. I hope you recall all of those values. If you do, then it is very easy to solve this question. Let's take a look at this first part. What does the first part say? The first question, this says in the LHS you have sine square pi by 6. Yes, this is sine pi by 6 and square plus cos square pi by 3 minus tan square pi by 4. And if you remember in terms of degrees, I'll basically use both degrees and radians. This sine pi by 6, which is actually sine 30 degree. The value is 1 by 2. This is 1 by 2 power 2. Cos pi by 3, which is cos 60 degree, is again 1 by 2. This is 1 by 2 and its square. Tan pi by 4 is tan 45 degree, which is 1. This is 1 square. Although you should remember in terms of radians as well, sine pi by 6 is 1 by 2, cos pi by 3 is 1 by 2. You should not always focus on converting in terms of degrees. Right? You should become more familiar with radians as well. Right? But if you are only familiar with degrees, convert this angle in terms of degrees and then think the value. Right? So this is 1 by 4 plus 1 by 4 minus 1, which is 1 plus 1 minus 4. That is equal to minus 2 by 4, which is minus 1 by 2. And yes, this is my RHS, and that's a complete proof. Hence, proved. Is that okay? Yes, this is okay. Let's discuss this question next. What does this question say? Prove that 2 sine square pi by 6 plus cosec square 7 pi by 6 times cos square pi by 3 is equal to 3 by 2. Now, once again, what we need is these values. If you know these values, or if we can calculate these values, then it is very easy to solve these questions over here. Let's take a look at how do we approach this. Sine pi by 6 is pretty simple. In the LHS, we have 2 times sine square pi by 6. Okay. We know the value of sine pi by 6, which is 1 by 2. We'll use that. What about cosec 7 pi by 6? Now, cosec 7 pi by 6 is not a standard angle. It is a allied angle, right? So, for cosec 7 pi by 6, what I need to do is I need to write it in the form of allied angle. This is slightly greater than pi. So, this can be written as cos of pi plus pi by 6, right? This is cos of pi plus pi. Cosec pi plus pi by 6. This is what I can write it as, pi plus pi by 6. This is what I can write it as. This is cosec square pi plus pi by 6, and that further can be written as, since this lies in the third quadrant, it will be minus cosec pi by 6, right? Don't make a mistake in that. This can be written as minus cosec pi by 6, and this here is cos square pi by 3, which is simple. Okay, so this becomes 2 times sine square pi by 6. What will that be equal to? This is 1 by 2. Sine pi by 6 is 1 by 2 whole square, plus, what is this? This is minus cosec pi by 6, and we have a whole square involved over here. Okay, we have a whole square over there, right? This is minus cosec pi by 6 whole square times cos square pi by 3. Cos pi by 3 is equal to what? This is equal to 1 by 2. So this will become 1 by 2 whole square. In the next step, what you get is this is 2 times 1 by 4, which is 1 by 2, and this becomes plus. Minus square would be actually plus cosec pi by 6. Now, what is cosec pi by 6 equal to? Cosec pi by 6 is the reciprocal of sine pi by 6, which is, the final value will be actually equal to 2. So, reciprocal of 1 by 2 would be 2. So, this becomes 2 square times 1 by 2 square. This is equal to 1. This is already a 1 by 2 and this is equal to 1. That gives me this equals 3 by 2, which is the RHS. Yes, that's the complete proof of this question. And is that all? Yes, that is all in this question. Let's discuss this question next. What does the question say? Prove that cot square pi by 6 plus cosec 5 pi by 6 plus 3 tan square pi by 6 is equal to 6. Now, what do we need over here? We already know the value of cot pi by 6, right? If you remember that, that's important. Tan pi by 6 is again standard between 0 to 10, pi by 2. Cosec 5 pi by 6. Now this is an angle which is greater than pi by 2. So for finding this value or for writing this value, we'll have to apply concepts of allied angles. This 5 pi by 6 is very close to pi by 6. It is slightly smaller than, it is very close to pi, and it is slightly smaller than pi. What is this equal to? This is pi minus pi by 6. So cosec 5 pi by 6 can be written as, let me write it separately over here. What can I write cosec 5 pi by 6 as? Cosec 5 pi by 6 is equal to cosec of pi minus pi by 6. Now this is actually the second quadrant. In the second quadrant, cosec will be a positive value. This is plus cosec pi by 6. This is equal to plus cosec pi by 6. Right? We can use that. The LHS. LHS is equal to what? This is cot square pi by 6 plus cosec 5 pi by 6, which is pi minus pi by 6, and plus 3 times tan square pi by 6. This is what I have in the LHS. Now let's take a look at each and every value one by one. Cot pi by 6 will be equal to what? Cot pi by 6 is 1 upon root 3. It is tan pi by 3. So this is 1 by root 3. This is equal to 1 by root 3. 1 by root 3, no, it's not 1 by root 3, it is root 3, right? Cot pi by 6 will be the reciprocal of tan pi by 6, which is 1 by root 3. So therefore this would be root 3, and the square of root 3 is what you get over here, right? Cot pi by 6 is root 3, therefore root 3 square. What happens to this cosec pi minus pi by 6? It is equal to cosec pi by 6, and the value of cosec pi by 6 is something which we know. And the value of cosec pi by 6 is the reciprocal of sine pi by 6. That is reciprocal of 1 by 2, which is 2. Okay, so this is 2 plus 3 times. What about tan pi by 6? Tan pi by 6 is 1 by root 3. This is square. So 1 by root 3 whole square is what you get over here. What does this give us? This is 3, this is 2, and this is 3 upon 3, which is 1. The overall sum is 6. This is equal to the RHS. And yes, that's the complete proof for this question. Hence, proved. Is that all? Yes, that is all in this question. Let us talk about the next one. What does this question say? Prove that 2 sine square 3 pi by 4 plus 2 cos 2 pi by 4 plus 2 sec square pi by 3 is equal to 10. Now in this question, we'll have to make a small correction. Let's make that correction first. What correction are we talking about over here? Let's take a look at this. This here is not 2, this is actually square. This is 2 cos square pi by 4. Right, let's make that correction. And then what are we supposed to do? We are supposed to take care of this sine 3 pi by 4 first of all. Now sine 3 pi by 4, let me simplify it here. Sine 3 pi by 4 can be written as sine of pi minus pi by 4. This is sine of pi minus pi by 4, which is equal to sine pi by 4, which is 1 by root 2. This is something which you will require, right? Sine 3 pi by 4 is allied angle, and this is what you require. Anything else? Cos pi by 4 is directly known. Sec pi by 3 is directly known. What is the value of cos pi by 4? If you may recall, cos pi by 4 is 1 by root 2. Sec pi by 3 is reciprocal of cos pi by 3. That's reciprocal of half, which is 2. This value is 2 over here. So LHS is 2 sine square 3 pi by 4. Okay, or I can write it as this is 2 sine square pi minus pi by 4 plus 2 cos square pi by 4 plus 2 sec square pi by 3. Take care of this correction. Take care of this correction. Okay, so what do we need further? This is 2 sine square pi minus pi by 4, which is actually equal to 1 by root 2. This is 2 times 1 by root 2 whole square over here. This is this. Cos square pi by 4. This is 1 by root 2 again. This is 1 by root 2 whole square plus 2 times sec square pi by 3. This is reciprocal half, which is 2 whole square. This is what I get. What will this simplify into? This is 2 by 2, which is 1 plus 1 again, and this is 8 over here. The overall sum is 10, which is equal to the RHS. And can you observe that? Yes, this is what we started with. This is what we wanted to prove. That's a complete proof of this question over here. Next, let us talk about this question. What does the question say? Find the value of sine 75 degree. Now, how do we go about finding the value of sine 75 degree? 75 degree is not yet a standard angle, but from now onwards, we would also like to remember. After finding this value, we would also like to remember this value of sine 75 degree. Now, what does sine 75 degree look like? 75 degree is actually the sum of 75 degree is actually the sum of two angles whose values are well known, 30 degree and 45 degree. We know sine 30 cos 30, we know sine 45 degree cos 45 degree, we know all of those things, right? 75 degree is actually a sum of these particular angles, right? So for finding sine 75 degree, what I'll do is I can write it as sine 30 degree plus 45 degree, right? And after writing it as sum of two angles and then sine, we can apply the formula of sine A plus B. Now what does the formula of sine A plus B look like? Sine A plus B is actually equal to sine A cos B plus cos A sine B. This is what it looks like, right? This is what it looks like. So we can apply that formula. Okay, let's do it. This is sine A plus B, which is sine A cos B plus cos A sine B. This is what you have. Sine 30 degree cos 45 plus cos 45 degree sine 30. Sorry, sine 30 cos 45 plus cos 30 sine 45 degree. That's what you get, right? I hope that's correct. Yes, this is correct. Sine 30 degree. What's the value of sine 30 degree? We know that sine 30 degree is 1 by 2. Cos 45 degree is 1 over root 2. Plus, what's cos 30 equal to? Cos 30 degree is root 3 by 2. Sine 45 is 1 by root 2. So this is 1 upon 2 root 2 plus root 3 over 2 root 2, and yes, this gives me the value root 3 plus 1 over 2 root 2, and that is my answer. This is the value of sine 75 degree. Should we remember this value? Yes, for future prospects, yes, you should remember this value. What other values along with this can we remember? We can further remember that sine 15 degree. For sine 15 degree, what we would be required is 45 minus 30. Can you observe? This would have been 45 minus 30. There would have been minus here, minus here, minus here. Okay, this term would have been minus actually, and you would have obtained root 3 minus 1 by 2 root 2. Okay, sine 15 degree is also equal to, by the complementary angles rule, this is also equal to cos 75 degree. Okay, sine 75 degree, as you can clearly observe, is root 3 plus 1 over 2 root 2, which will be equal to cos 15 degree, right? This is 15 and 75, the sum is 90 degree. These are complementary angles, right, of each other. And on the basis of this, I can define something called tan 15 degree. Tan 15 degree would be sine 15 degree upon cos 15 degree. That's the ratio of these two, right? Ratio of these two would be, the 2 root 2 will get cancelled, and what you get is root 3 minus 1 upon root 3 plus 1. And the important thing is that you can further simplify it by rationalizing the denominator. By rationalizing the denominator, what you will get is root 3 plus root 3 minus 1 upon root 3 minus 1. That will be root 3 minus 1 whole square upon 2. And this will further convert to 2 minus root 3. You can simplify that further, right? This is another value. But tan 15 degree can also be equal to cot 75 degree, right? So if you ever see cot 75 degree, will you be able to tell the value now? Yes, you will be able to tell the value now with the help of this, right? Although you can find tan 15 degree directly as well. Tan 15 degree can be found in this manner as well. Tan 15 degree can be written as tan of 45 degree minus 30 degree. We know tan 45 degree, we know tan 30 degree, and we can simplify that to get this value. That will not be difficult, right? Okay. Similarly, can we also find tan 75 degree? Yes. Tan 75 degree can be found using the general method, or you can find tan 75 degree from here and memorize this. Tan 75 degree would be sine 75 upon cos 75, this upon this. That will be equal to root 3 plus 1 over root 3 minus 1, which will actually simplify to this 2 plus root 3. Now tan 75 degree is also equal to cot 15 degree. This is equal to cot 15 degree. So we'll remember these values, right? We'll remember these values. Along with this, we'll remember one more thing. And what is that? 15 degree in terms of radians. Now 15 degree in terms of radians, what is that equal to? So 15 degree in terms of radians would be equal to pi by 12. Not only that, 75 degree in terms of radian is 5 pi by 12. These are two standard angles which you can remember from now onwards. The values, first the values of sine 15, sine 75 degree, tan 15, tan 75 degree, on the basis of which we can also find these, right? Cos 75, cos 15, cot 75 and cot 15 degree, right? These are some values which you remember. But instead of 15 degree, if you encounter radians, so you should not be worried too much. what you'll have is sine 15 degree is same as sine pi by 12. So if you see sine pi by 12, yes, you know the value of sine pi by 12 now. Okay, so in any case, if you see such kind of question again, or such kind of values, if you're asked such values, you'll be able to answer those questions as well, right? Is that all? Yes, that is all for this question over here, along with some extra useful information for you. Let's move on to the next one after this. How do we find tan 15 degree, right? We just saw the value of tan 15 degree. If you may recall, we've just solved and found the value of tan 15 degree, but can you actually solve this tan 15 degree directly using 45 degree and 30 degree? Maybe, yes. Now 15 degree can be written as 45 minus 30 degree. So tan 15 degree is equal to tan 45 degree minus 30 degree. And tan of A minus B, the formula of tan of A minus B, can I use that? Yes. Tan of A minus B looks like tan A minus tan B over 1 plus tan A tan B. Okay, this is simple, yes. So this is tan A minus B, which is tan A minus tan B over 1 plus tan A tan B. This is what you get, right? Tan A minus tan B upon 1 plus tan A tan B. Now what is tan 45 degree equal to? Tan 45 degree is 1. What is tan 30 degree equal to? That is 1 upon root 3. So this is 1 minus 1 by root 3, which is upon 1 plus 1 times 1 by root 3. Now what does this simplify into? This gives me tan 15 degree can be written as, we'll have to take the LCM. This is root 3 minus 1 over root 3 whole divided by, this is root 3 plus 1 over root 3, and yes, this one further simplifies into root 3 minus 1 over root 3 plus 1. And on rationalizing, what does this simplify into further? On rationalizing, that is multiply with root 3 minus 1 and root 3 minus 1 over here. This gives me root 3 minus 1 whole square upon 3 minus 1 in the denominator. Can you simplify this square as well? Yes, this will be equal to 3 plus 1 minus 2 root 3 whole divided by 2. What is that? This is 4 minus 2 root 3 over 2, or we can say that tan 15 degree is equal to 4 by 2, which is 2 minus root 3. Right, this is the final value, and that is my answer for this question over here, right? But if you heard the first part, you would have already found the solution using some other approach as well, but this is the actual solution that the NCERT people would want you at this location, right? This tan 15 degree is equal to 2 minus root 3. That is your answer. Obviously, there are other approaches, one of which I discussed with part 1, right? And finally, we'll have to remember this, right? Finally, we'll have to remember this one, right? Let's solve this question next. Prove the following. What does this question say? This is part 6 of exercise 3.3. Exercise 3.3, question number 6. What does this question say? In the LHS, we have a big expression, cos of pi by 4 minus x, cos of pi by 4 minus y, minus sine of pi by 4 minus x, sine of pi by 4 minus y. Okay, so since we have a big expression, let's see how we can simplify. How can we simplify this? If I observe clearly, carefully, what I see is, this is pi by 4 minus x, this is also pi by 4 minus x, this is pi by 4 minus y, this is also pi by 4 minus y. So what you have, in principle, what we have over here is cos of angle A, cos of angle B, minus sine of same angle A, sine of same angle B. Okay, this is cos A, cos B minus sine A, sine B. That's pretty simple to handle, yes. So in the LHS, what we have is cos of pi by 4 minus x, cos of pi by 4 minus y, minus of sine pi by 4 minus x, sine pi by 4 minus y. And this looks like cos A, cos B minus sine A, sine B. What is this formula equal to? Cos A, cos B minus sine A, sine B. This is nothing but the formula of cos A plus B. So this can be simplified and written as cos of A plus B. This is what I can write it as, right? Since cos A, cos B minus sine A, sine B is equal to cos of A plus B, so this LHS becomes equal to cos of the sum of these two angles. What is that? Pi by 4 minus x plus pi by 4 minus y. This is what you get. Have we reached that final stage? No, we needed a single sine. We have arrived at a single cos, but you may observe that this can be simplified very easily now. Pi by 4 plus pi by 4 is pi by 2 minus of x plus y. This is what you have over here, right? This is a complete angle. And cos of pi by 2 minus some angle theta. Cos of pi by 2 minus theta is nothing but sine theta. So this is sine x plus y. Since we know that cos of pi by 2 minus theta is equal to sine theta. Using this result over here, cos of pi by 2 minus theta is simply sine theta using this. And yes, this is the RHS, and yes, that is our proof for this question. Is that all? Yes, that is all for this question. Let us take a look at this question next. What does the question say? Seventh part. This says tan of pi by 4 plus x over tan of pi by 4 minus x is equal to this complicated expression 1 plus tan x over 1 minus tan x whole square, right? Once again, the LHS, which looks more complicated, the LHS or the RHS? For me, the LHS looks pretty complicated. Tan of pi by 4 plus x has a lot of things involved, right? So let's take a look at this. Tan of pi by 4 plus x. Let's take a look at this. In the LHS, you have in the numerator tan of pi by 4 plus x. In the denominator, you have tan of pi by 4 minus x. Okay. Now this is tan of a plus b, tan of angle a plus angle b, tan of angle a minus tan of angle b. Can we apply the results for that? Yes. So we have some more difference of angles. This is tan pi by 4 plus tan x over 1 minus tan pi by 4 times tan x. This is what you have in the LHS, numerator of LHS. What about the denominator of LHS? Let's take a look at the denominator as well. In the denominator, you have tan of a minus b, which will be tan of pi by 4 minus tan x over 1 plus tan of pi by 4 times tan x. This is what you have in the denominator and the numerator respectively, right? What did we apply over here? Let me write the formula. Tan of a plus b is equal to, if you do not remember this formula, it is very difficult to solve this kind of a question, right? You should memorize this formula. Let me recall this formula. This is tan a plus tan b over 1 minus tan a into tan b, right? And tan of a minus b, for tan of a minus b, this will become tan of a minus tan of b, and this will become 1 plus tan of a into tan of b. And that's what you have used over here. Okay, using this formula. Next, after this will simplify to further, what will this simplify to? Tan of pi by 4, tan of pi by 4 is simply 1. So, this numerator will become 1 plus tan x. This denominator will become 1 minus 1 times tan x, which is 1 minus tan x. This is the numerator, right? Overall denominator would become 1 minus tan x over 1 plus tan x. Okay. Now we can reach this stage. That is something which may be possible easily by simply writing the numerator, this 1 minus tan x divided by this whole thing would actually imply multiply with the reciprocal. This is 1 plus tan x over 1 minus tan x, right? This divided by this would imply this multiplied by the reciprocal of this, right? That's what you have done, reciprocal of this. This denominator will come in the numerator. That's what happens over here, and this becomes 1 plus tan x whole square in the numerator, and in the denominator you have 1 minus tan x whole square. Yes, it can be written in this form, and yes, this is the RHS. That's the complete proof. This is the RHS, and that's the complete proof of this question over here, right? What is so special about this kind of a thing? Something which is very special. Let me ask you one thing, that if tan of pi by 4 plus x is given, you can simply write it as tan of pi by 4 plus x can be written as this 1 plus tan x over 1 minus tan x. But then someday you may encounter this, and writing it back in this form would be required, and you should be able to do that on that particular day. So this is something which is special, right? This is something special which people generally tend to forget and do not apply actually when this particular kind of question comes. right? For example, if I ask you the value of find x when 1 plus tan x over 1 minus tan x is equal to tan 67 degree. If this is asked, let us say. So can you find the value of x easily? Yes, you can find the value of x easily if you know this. Otherwise, you will keep on solving, but you will not get anywhere. Since this is equal to tan of pi by 4 plus x, this can be done as tan 45 degree plus x. Now we are dealing with degrees over here in the RHS, so we'll use degrees only, right? This is equal to tan 67, and one of the possible values which lies acute angle x can easily be found as x would be equal to 67 minus 45. Mind you, acute angle x can be easily found by subtracting these two. 67 minus 45 would be 22 degree. The answer would be yes, 22 degree for acute angle x. Otherwise, you will have in general solution, you will have many more values of x also possible. But this particular question can be solved using this kind of approach, and such things are useful for actually solving questions, actually solving equations, right? Is that all? Yes, that is all in this question over here. Let's try and solve this question. What does the question say? Cos of pi plus x, cos of minus x, sin pi minus x, cos of pi by 2 plus x. All of those things are in the LHS, and is this equal to cot square x? Let's check out. Let's check this out. What do we have over here? Is this. So in the LHS, what we have are some allied angles. This is cos of pi plus x, cos of minus x, and sine of pi minus x, cos of pi by 2 plus x. This is what you have, right? So what are we supposed to do? We are supposed to find the value of cos pi plus x first. Cos of pi plus x means this angle is lying in the third quadrant, right? In the third quadrant, cos is negative. This is minus of cos x. Okay, times, what is this equal to? Cos of minus theta is same as cos theta. This is cos of x only. What about the denominator? Sine of pi minus x. This is the second quadrant. Sine is positive. This is simply sine of x. Okay. What about this? Cos of pi by 2 plus x. Cos in the second quadrant. This is second quadrant. Cos in the second quadrant is negative. As well as this is pi by 2. So cos will actually convert into sine, and this will be minus sine. This will be equal to minus sine x, using concepts of allied angles directly. Right. This will convert to minus cos square x in the numerator, minus sine square x in the denominator, and the minuses get cancelled, and this becomes cot square x, which is the RHS. And yes, that's a complete proof for this. This is what we wanted, right? That is all in this question. Let us take a look at this question. Cos of 3 pi by 2 plus x, cos of 2 pi plus x times a huge bracket. What does that bracket have? Cot of 3 pi by 2 minus x, cot of 2 pi plus x, and that product is equal to 1. This is what is being asked. So for proving this, once again, we need something called concepts of allied angles. What are concepts of allied angles that will require over here? What is cos of 3 pi by 2 plus x equal to? That is something which you require. Cos of 2 pi plus x is pretty simple. Cot 3 pi by 2 minus x and cot 2 pi plus x, which is once again very simple. So let's begin with the LHS. Cos 3 pi by 2 plus x is what we require, times cos of 2 pi plus x, and in the bracket what you have is cot 3 pi by 2 minus x plus, what is this? This is cot of 2 pi plus x. That's what you have, right? So let's take a look at this. Cos 3 pi by 2 plus x, we are actually looking at the fourth quadrant over here. In the fourth quadrant, cos is supposed to be positive, but since this is 3 pi by 2, that is odd multiple of pi by 2, cos will convert in terms of sine. So this is actually equal to sine x. This is equal to plus sine x, right? Using concepts of allied angles. What is this equal to? Cos of 2 pi plus x is same as x. What about this over here? Cot of 3 pi by 2 minus x. Let's recall cot of 3 pi by 2 minus x. 3 pi by 2 minus x is actually this quadrant, right? 3 pi by 2 is that line, and 3 pi by 2 minus x is that quadrant. This is the third quadrant. In the third quadrant, cot is positive, but 3 pi by 2 will convert, because of 3 pi by 2, cot will convert in terms of tan. So this is plus tan x. What about 2 pi plus x? 2 pi plus x is pretty simple. This is the angle that I'm looking at. This is the location that I'm looking at. And in the first quadrant, cot of 2 pi plus x would be actually equal to simply cot pi only. This is cot of x, right? This is what you have. So tan x plus cot x in the bracket and sin x times cos x over here. This is what we have. This is sin x times cos x times, what is this? Tan x and cot x can further be written in terms of sine and cos, and what you get is this is sin x over cos x plus cos x over sin x, right? This is what we have. And can we take the LCM to simplify this further? Yes, let's do it. This is sin x cos x, which is okay. What about this? This becomes sine square x plus cos square x in the numerator. And what you get in the denominator is sin x times cos x. Pretty interesting. Why? Because we already have a sin x times cos x in the numerator. We get something in similar thing in the denominator. These things will get cancelled, and what we get is sin square x plus cos square x. Sin square x plus cos square x is nothing but 1. And yes, the same value is there in the RHS. So this is equal to RHS. Is that all? Yeah, that is all. This is the complete proof of this question. Is that all? Yes, that is all. That's the complete proof. What we have used is simple concepts of allied angles. Simple concepts of allied angles. On the basis of that, it was very easy to solve this question. Let's talk about this question next. Prove the following. Sine of n plus 1x times sine of n plus 2x plus cos of n plus 1x cos of n plus 2x. Okay, and this is equal to cos x. That's what the person is saying. How do we go about solving this? Please observe that the angles, special, this is n plus 1x. Similarly, you have an n plus 1x over here as well. Okay, this here is n plus 2x. And similarly, you have an n plus 2x over here as well. Okay, so you have same angles at two different locations. And imagine, this is basically, imagine this as A, this as B. This is cos A, cos B plus sin A, sin B. Oh, that's a particular identity, and we remember that identity, right? What is this equal to? This is a form, expanded form of actually cos of A minus B. What do you mean? Cos of A minus B, what was that? Recall, cos of A minus B is equal to cos A cos B plus sin A sin B. Okay, this is cos A cos B plus sin A sin B. This will convert to cos A minus B. Yes, this will convert to cos A minus B. So, let us simplify the LHS. LHS is equal to cos of n plus 1x times cos of n plus 2x plus sine of n plus 1x times sine of n plus 2x. Okay. And once we have this clarity in our mind, we can observe that since cos A cos B plus sin A sin B is equal to cos of A minus B. Cos of A minus B. This can be done as cos of A minus B. Yes, we can take this as A and this as B. This is also possible, right? This is possible, and we can take it as this. Since this is equal to this LHS becomes equal to cos of this minus this. Okay. Could we have taken this minus this as well? You would observe that it will not make much difference. Right. Why? Let's observe. This is n plus 1x minus n plus 2x over here. And what does this simplify further? How does this simplify further? This is cos. Cos is okay. Okay. In the bracket, what you have is we can take a x common. We can take x common, and n plus 1 minus n minus 2 will come over here. What is this? N and n get cancelled. This is 1 minus 2, which is minus. So this is cos of minus x. Okay. What is cos of minus x further equal to? Cos of minus x. Cos of minus theta is also equal to cos theta. So this can be written as cos x. Yes. Therefore, I said that writing it as cos of A minus B or cos B minus A will not have an impact, since cos of minus theta is also equal to cos theta. So cos minus x is also equal to cos x, and yes, that is something which you required. This is my RHS, and that's the complete proof of this question over here. Is that all? Yes, that is all in this question. Let's discuss this question next. What does the question say? Prove the following in 11th. Question number 11th, what does it say? We have cos of 3 pi by 4 plus x minus cos of 3 pi by 4 minus x in the LHS, and that is supposed to be equal to something. How do we go about proving this one? Let's take a look at this. This is a relatively pretty simple question. What do we have? We have cos of 3 pi by 4 plus x and cos of 3 pi by 4 minus x. There's not much we can do with both this by combining these. Can we do something with combining this? Yes. We can combine them together by something called transformation. So what is the result that I want to use over here? I can use cos of cos C minus cos D. Cos C minus cos D. This is one angle C. This is another angle D. This is one approach that I am using over here. This is cos C. Let's use cos C minus cos D is equal to, that will be equal to 2 sine C plus D by 2 and sine, you can write it as C minus D by 2 and introduce a minus over here, or we can take that minus inside and write it as sine of D minus C by 2. So if you are familiar with C minus D by 2, I'll write a minus over here. This is one version, minus 2 times sine of C plus D by 2, sine of C minus D by 2. This is one formula. And first, let us take a look at this question using this approach. Okay, let's do it. What do we have? In the LHS, we have cos of 3 pi by 4 plus x minus cos of 3 pi by 4 minus x. This is what we have. Okay, let's observe this angle as C and this angle is D. Let's observe this angle as C and this angle is D. This is cos C minus cos D, which will become minus 2 sine C plus D by 2. What is that? 3 pi by 4 plus x plus 3 pi by 4 minus x whole divided by 2. That's one thing. What else? Next you have sine of C minus D by 2. Now what is C minus D? C minus D is this angle minus this angle. So this will be 3 pi by 4 plus x minus 3 pi by 4, and you'll have minus of minus x, which will become plus x whole divided by 2. This is what it simplifies to. What else? This minus 2 remains as it is. This becomes x gets cancelled. This is 3 pi by 4, 3 pi by 4, which will add up to 3 pi by 2. By another 2 would be actually 3 pi by 8. Sorry, 3 pi by 4. This is sine of 3 pi by 4. What is that equal to? 3 pi by 4 gets cancelled. X plus x is 2x. 2x upon 2 will be x. So this is sine of x over here. Right? Those are the angles. So we have reached a stage where we have sine x, yes, and we have some sine, right? And can we find the value of this? This is sine 3 pi by 4, which can be done as sine of pi minus pi by 4, right? Using allied angles, this can be written as sine of pi minus pi by 4. Okay, and the value can be easily found, right? This is sine of pi minus pi by 4 times sine x. Minus 2 times sine of pi minus pi by 4 would be actually equal to sine pi by 4, right? Plus sine pi by 4, and sine pi by 4 is actually 1 by root 2. This is 1 by root 2. This is sine x. What will this convert to? This is minus root 2 times sine x, and yes, this is my RHS as can be observed over here. Is that all? Yes, that's the proof. Complete proof. Now we can have another approach of solving this question. We could have another approach of solving this question, that is by simply expanding this using ideas of cos of a plus b. Cos of a plus b would be equal to cos a cos b minus sin a sin b. This here would convert to cos of a minus b, which is cos a cos b plus sin a sin b, and we can use that idea as well to solve this question. So let us take a look at the method 2 for solving this. So method 2, what does it say? LHS can be simply expanded, right? This will be cos of 3 pi by 4 plus x, and this here is cos of 3 pi by 4 minus x. By the way, if you may recall, you can use another identity, but I am just using the direct approach over here. This is cos of 3 pi by 4 cos x minus sin 3 pi by 4 sin x, right? What is this expression? This expression is minus this, right? So minus of what you have is cos a cos b, which is cos 3 pi by 4 times cos x, okay? And see this carefully, this is cos a cos b plus sin a sin b. You have a minus, so this becomes minus cos a cos b, and again minus of sin 3 pi by 4 sin x. This is what you get, right? Is that simple? Yeah. So these terms, as you can see, this term get cancelled, and what you have is these are similar terms, so it becomes minus 2 sin 3 pi by 4 times sin x, And after this, yes, this stage, and in the previous method also we reached this stage. After this, we simply wanted to simplify this sine 3 pi by 4 using allied angles concept. This is minus 2 sine of 3 pi by 4 can be done as pi minus pi by 4 times sine x. This is what you get. Minus 2 is okay. Sine of pi minus pi by 4 is sine pi by 4, which is 1 over root 2. This is sine x. Okay, and yes, this becomes minus square root of 2 times sine x, which is my RHS. And that's the complete proof of this question, which is my RHS. And yes, this is the complete proof for this question over here. Let us solve this question next. What does the question say? We have sine square 6x minus sine square 4x, which is equal to this. How do we approach this question? How do we approach this question? We have a few methods which we can use. One of the results, if you remember one particular result, okay, this is not given in the NCERT, but if you remember that result, this question becomes direct. What is the result? Result is sine square A minus sine square B. This is equal to sine A plus B times sine A minus B. Now, since I am giving you a new result, yeah. If you have studied only from the NCERT, you would not encounter this result. But then, if you know this result, you can solve this question directly. Okay. Okay. So, is this some kind of a trick? No, this is no trick. We have a proper proof of this. So, tell us the proof. Okay. We can take a look at the proof. Yes. So, instead of going from the LHS to RHS, what I will do is I will simplify from the RHS. Oh, why are you doing that? We can also go from the LHS, but going from the RHS would be easier for you to understand right now. So, sine of A plus B is sine A, sine A cos B. So, let me write it in terms of short, sine A cos B, okay, sine A cos B plus cos A sine B, right? Let's write it as this. This is one factor. The other factor is just sine A cos B minus cos A sine B. This is another factor, right? So, can you please observe that this is x plus y, this is x minus y, which will convert to simply x square minus y square. This is sine square A cos square B minus cos square A sine square B. And you can observe that I need the final result in terms of sine and sine. So, let us convert this cos square B and this cos square A in terms of sine square. How do we do that? Sine square A is okay. Cos square B can be done as 1 minus sine square B, right? Since cos square B plus sine square B is equal to 1, we can write cos square B as 1 minus sine square B very easily, right? What else? This is cos square A, which is 1 minus sine square A, and this is sine square B over here, okay? What next? What next? This is sine square A minus sine square A times sine square B minus, what is this? This is sine square B and plus sine square A times sine square B is what I get over here, right? This is what I get. Keeping this in mind, these terms will get cancelled, and what I'll have is sine square A minus sine square B. As you can observe, this is this result, right? This is one important result, which if you remember this result, you can directly solve this one. But then, do we remember this? No. So, we should have another kind of approach, yes. Let me solve with this approach first. This is sine square A minus sine square B. This will become sine of A plus B. The sum of these two angles would be 6x plus 4x, which is sine 10x, times sine of difference of two angles, sine 6x minus 4x, which is sine 2x. You can see this question becomes oral after this. But then, without using this, we should be able to solve it without using this over here. And how do we do that? That's also possible using simple concepts of transformation. What are the concepts of transformation? Let's take a look at that over here. Sine square 6x minus sine square 4x. It is actually written in the form a plus b, a square minus b square. Can we simplify it as a plus b times a minus b? Yes, we can simplify it in the LHS as this. LHS is sine square 6x minus sine square 4x. Okay. This can be done as sine 6x plus sine 4x times, this is a plus b times a minus b, which will be sine 6x minus sine 4x. This is what you have, right? What next? Next, I would like to apply some concepts of transformation. Concepts of transformation imply that I have formula of sine C plus sine D. What is the formula for sine C plus sine D? This is equal to 2 sine C plus D by 2 sine 2 sine C plus D by 2 cos C minus D by 2. This is one version, right? This is cos C minus D by 2. That's what we have, right? From the sum or difference, we are trying to convert into a product, because in the RHS we have a product only, right? Okay, sine C plus sine D is 2 sine C plus D by 2 cos of C minus D by 2. And what is sine C minus sine D? Sine C minus sine D will be equal to, you should remember this one as well. This is 2 cos C plus D by 2 sine C minus D by 2. Now these are properly given in the NCERT, right? You should be aware of these, right? These are very useful identities. Conversion of sum or difference in terms of product. Okay, this is something which we have. So let's simplify this further. What do we have over here? Is sine C plus sine D, which can be done as 2 sine C plus D by 2. What will that convert into? C plus D by 2. This will be 6x plus 4x by 2, which is 10x by 2. Sine C plus D by 2. Cos of C minus D by 2. Now what is C minus D? 6x minus 4x, which is 2x by 2. What next? This is sine C minus sine D, another product, and that will be equal to 2 times cos of C plus D by 2. 6x plus 4x is 10x by 2 times, this is 2 cos C plus D by 2, and you have sine of C minus D by 2. C minus D, which is 6x minus 4x, which is 2x by 2. Okay, this is one identity that we have used. What else? This is written as 2 sine 5x cos x into 2, what is this? This is cos 5x. Okay, this is sine x. But do you observe, where do you want to go? We want to go in this direction, right? Sine 10x is required, sine 2x is required. Now sine 5x and cos 5x can combine together to give you sine 10x using another identity of multiple angles. What is that? Sine 2a is equal to 2 sine a cos a. Or basically this identity in reverse can be used over here. Let's write this 2 sine 5x and cos 5x first. Let's write cos 5x first times 2 sin x, and let's take this cos x at the back. Okay. Now observe this carefully. This is 2 sin 5x cos 5x. 2 sin a cos a, which is sin 2a. This is sine of 2 times 5x, which is 10x, times 2 sin x cos x, which is sin 2x. This is what you have. Sin 10x sin times sin 2x, and yes, this is the right hand side, which can be found using this approach over here. These identities would be required. Yes, these identities from your NCERT directly will be required, and very useful identities, right? Very, very useful identities. Is that all? Yes, that is all in this question. Let's discuss this question in front of us. What does the question say? Cos square 2x minus cos square 6x, and this has to be proved equal to sin 4x times sin 8x. Now what are we supposed to do in this question? Let's take a look at this. Cos square a minus cos square b. Now this is a special identity which is actually not given in the NCERT, and if you want to hear it out, let me elaborate the identity in front of you. Let me write the identity. What do we have over here is cos square a minus cos square b. This is the version that we have, right? Can you observe that this is similar to in the previous question in the solution I have discussed sin square a minus sin square b, yes? And this is pretty much similar to that. This cos square a can be done as 1 minus sin square a, and this cos square b can be done as 1 minus of minus will become sin square b. So this actually becomes sin square b minus sin square a. Okay. And this will be equal to what? This will be equal to sine of b plus a times sine of b minus a. Sine of b minus a. This is what it will be equal to. Okay. And the proof of this is something which I have discussed in the previous question. You can refer to that solution. But What about this question? Can we use this identity over here? Had we been allowed to use this identity, the result would have been pretty simple. You can observe cos square A minus cos square B. Cos square 2x minus cos square 6x would be sine B plus A, which is 2x plus 6x is sine 8x. And sine 6x minus 2x. Sine 6x minus 2x, that will be equal to sine 4x, which is over here. The two products would have been obtained very easily. But then, if life would have been so simple, it would have been very easy. But this result is not known to us. So what is the result that we want to use over here? Let's see. In the LHS, what I observe is, what do the NCERT people want us to do, or what are we supposed to do for this question based on NCERT? Since this is NCERT series, let's talk about that. So cos square 2x minus cos square 6x, what will this look like? This can be written as, let's observe, this is a square minus b square. So we can write it as a, that is cos square 2x minus cos square 6x. Imagine this as a square minus b square. This can be written as a plus b times a minus b. This is cos 2x plus cos 6x times cos 2x minus cos 6x. I can write it as this, yes. What next? What next? I'll require two important transformation formulae. Now, what are those in transformation formulae that I would require over here? Is cos C plus cos D. That is something which I require over here. Cos C plus cos D is equal to what? This is equal to 2 cos C plus D by 2 cos C minus D by 2. And that is something which is given in your textbook, right? So this is something which you may be aware of. Then cos C minus cos D is equal to what? This is equal to, please take a look at this carefully, minus 2 sine C plus D, minus 2 sine C plus D by 2 sine C minus D by 2. Sine C minus D by 2. This is equal to this. Those are two important results, and those results can be used over here. Let's see. This will simplify to what? This will simplify to, this is cos C plus cos D. Cos C plus cos D. 2 cos C plus D by 2. This will convert to cos of C plus D by 2. 2 cos C plus D. That is 8x by 2. Cos of C minus D. 2x minus 6x. That will be minus 4x by 2. Okay, this is what I get. Is that okay? Yes, that's okay. What about the other one? This cos C minus cos D. Cos C minus cos D is again, this is minus 2 times sine of C plus D by 2. Now what is sine of C plus D is 8x by 2. And what about the other one? Sine of C minus D. C minus D. 2x minus 6x would be minus 4x. So this is sine of minus 4x by 2. This is what you have. Sine of minus 4x by 2. Okay. What else? Let's write this again. This is cos of 4x. Okay. This is cos of minus 2x. Now cos of minus 2x is same as cos of 2x. Cos minus theta is same as cos theta. So this can be done as cos 2x. Right. Pretty simple. What next? This is minus 2. Let it be. This is sine 4x. So let's take a look at this sine 4x. What is this equal to? Sine of minus 2x. Now that minus can come out, right? We left that, right? We left one, we have one minus already in the outside, and we'll get one more minus from here. That will become a plus. So this is again 2 times sine 2x is what will remain over here. What else? We'll have to rearrange some things. What you observe is 4x, cos 4x and sine 4x are there. And we remember one more identity, 2 sine x cos x is actually equal to sine 2x. Right? 2 sine a cos a is sine 2a. Right. So I can write it as 2 sine 4x times cos 4x. What I have done is I have simply brought the sine 4x over here. What remains is 2 cos 2x sine 2x. 2 sine 2x times cos 2x. And yes, this will convert to sine twice 4x, which is sine 8x, times sine twice 2x, which is sine 4x. This is what I'll get. And please observe the RHS. Does it look similar? Yes. This is same as the RHS. Hence proved. That's the complete result that we have. Is that all? Yes, that is all in this question over here. What next? Let us solve this question after that. What does this question say? Prove the following, 14 part. sine 2x plus 2 sine 4x plus sine 6x is equal to 4 cos square x sine 4x. Okay, what do we do in this case? Let's see. In the LHS, we have 3 terms as you can see. Okay, and can you please observe that this sine 2x can be easily merged with the sine 6x. We can actually use transformation formulae of transforming sum or difference into product. In the RHS, we only have the products, right? So we'll have to apply transformation formulae maybe twice. Let's do it. In the LHS, you have sine 2x plus sine 6x. And you have plus 2 sine 4x as well. Okay, what else? What I'll do is I observe that sine C plus sine D is equal to 2 sine C plus D by 2 cos C minus D by 2. That's what I have. Once you are through with this, once you know that result, let's use that on this. This will convert to 2 sine C plus D 8x by 2 cos C minus D. What is that? 2x minus 6x is minus 4x by 2. This is sine C minus D by 2. What next? This is simply plus 2 sine 4x. Let's leave it at that for something. And this becomes 2 sine 4x. Okay. This becomes cos of minus 2x. Now, cos of minus theta is same as cos of theta. So I can write it as cos of 2x. That 2 sine 4x remains as it is. Okay, what next? Do you observe that you can take out a 2 sine 4x common from both of these terms? Yes. What remains is cos 2x over here and plus 1 over here, right? The only factor that will remain is this. Right. What else? Can this 2x be simplified, cos 2x be simplified into something? Yes, I can simplify cos 2a can be written as, cos of 2a can be written as 2 cos square a minus 1. I want to use this result. Cos 2a can be equal to plenty of other things as well. What are the other things? Let's recall those results also side by side. This can be done as, this is, the original version is cos square a minus sine square a. Then you have this version. You can also have 1 minus 2 sine square a. This is another version. Do you remember another version other than this? Yes, there's one more version. What is that? 1 minus tan square a over 1 plus tan square a. All of these can be derived from this one over here. You can write cos square a as 1 minus sine square a. This will be converted to this form. You can write sine square a as 1 minus cos square a. This can be converted in this form. And you can divide it with 1. What is 1? In trigonometry, 1 is simply equal to sine square a plus cos square a. So divide this by sine square a plus cos square a, and further in the numerator and denominator, you divide by cos square a and convert in terms of this. This is what you have. So cos 2a can be simplified in any of these forms. Right. Which form do I require? I require cos 2x is equal to 2 cos square x minus 1. So let's use that. This is 2 sine 4x, which is pretty simple. In the bracket, you have 2 cos square x minus 1 plus 1. This will be 2 cos square x. And is that what we require? Yes. This is 2 times 2 is 4 cos square x times sine 4x. Take a look at the RHS. Do they look similar? Yes, they look similar. Hence, proved. That is all in this question over here. Take a look at these results properly so that you can use them for your reference, right? Write them down and remember them properly. That is all in this question over here. Let us solve this question. 15th, cot 4x times sine 5x plus sine 3x. This is what you have in the LHS. In the RHS, you have another complicated expression, cot x times sine 5x minus sine 3x. This is what you have in the RHS. Can you please observe that both LHS and RHS have complicated expressions. Okay. So the general method of proving that we follow is you start with the LHS and try to simplify it into the RHS. RHS is generally a simplified expression. Okay. But here both LHS and RHS are complicated. So in that case, what can be done? one of the approaches that we can follow is, okay, so let's start from this complicated expression, simplify it and try to convert it into this form. That will be difficult, right? Another approach of proving is you simplify the LHS into something, you simplify the RHS into something, and they become equal. That's a simple way of proving. You are converting this into some form, you are converting this into some form, and if they both are equal, then obviously the LHS will be equal to the RHS. Yes, that's a simple approach which will work over here. Another idea which could have been used in this question is, first you remodel the question. Okay, first you remodel the question and then you solve. Okay, a remodeling would work over here. Yes, a remodeling would be very beneficial over here. Let's take a look at that method 1 over here. Method 1. Okay, now some people may not love this method, but some teachers of your school may not love this method, but that does not make a difference. This method is perfectly okay, keeping in mind certain restrictions, right? Keeping in mind certain restrictions. So let's take a look at method 1. What I have is given cot 4x times sine 5x plus sine 3x is equal to what? Is equal to, you have cot x outside and you have sine 5x minus sine 3x on the inside. Cot x, and in the bracket you have sine 5x minus sine 3x. Okay, I want to remodel this. Okay, how do you want to remodel this? What I want to do is, I want to bring the complicated terms together and the non-complicated terms together. What I'll do is sine 5x plus sine 3x, let's divide by this term over here. Let this remain over here and divide by that bracket on both sides. What about this cot 4x? We'll take it on the right hand side. This is in product, we'll take it on the right hand side. This is sine 5x minus sine 3x, okay, which is equal to, can you observe there's a cot x in the numerator and you will get a cot 4x in the denominator. This is what you get, right? And now I'll try to prove this one first. So proof, let's take a look at the proof of this one. Now the LHS at this stage is complicated, whereas the RHS is simplified, right? So this becomes a general proof, regular thing, and we can handle this. This is sine 5x in the numerator, and in the denominator you have sine 5x minus sine 3x. Okay, how do we simplify this? In the numerator you have something looking similar to sine c plus sine d, right? So what is the identity for sine c plus sine d? This is a familiar identity, right? Sine c plus sine d is 2 sine c plus d by 2 cos c minus d by 2. This is what you have. What about the denominator? In the denominator I have something which looks like sine c minus sine d. Okay, and sine c minus sine d is also a familiar identity, very important one. This difference can be converted into product. What is this equal to? This is 2 cos c plus d by 2 sine c minus d by 2. We can use these two identities to simplify this expression. How do we do that? In the numerator, you observe this is sine 5x plus sine 3x, which is similar to sine c plus sine d. Sine c plus sine d is 2 sine c plus d by 2 cos c minus d by 2. So instead of c you have a 5x over here, instead of a d you have a 3x over here, okay, and they can be converted in that form. This will convert to 2 sine 5x plus 3x by 2, okay, which will be sine 8x by 2. This will 2 sine 5x plus 3x 8x by 2 and cos of 5x minus 3x by 2, right, sine c minus d by 2. Cos of, what is 5x minus 3x? That is 2x by 2. In the numerator you get this. What about the denominator? In the denominator you have sine 5x minus sine 3x, which is equivalent to sine c minus sine d. That will be equal to 2 cos c plus d by 2 sine c minus d by 2. This is 2 cos 5x plus 3x by 2. 2 cos, what is 5x plus 3x? That is 8x by 2. Sine 5x minus 3x by 2. Clearly observe that this is 2x by 2, right? Can we simplify this further? Yes. Let's simplify this further. Therefore, LHS is equal to what? Let's take a look at the LHS. You have 2 sine 4x sine cos x. 2 sine 4x cos x in the numerator. What about the denominator? Do you observe? You have 2 cos 8x by 2, which is 4x, sine 2x by 2, which is sine x. This is what you have in the denominator. And let's cancel these factors of 2. Sine 4x upon cos 4x. This will be equal to, in the numerator you have sine x, sine 4x over cos 4x. In the numerator it can be converted into tan 4x, or if you require, if you want to write it in terms of cot 4x, let's write cos upon sine. In the denominator you have cot 4x. Okay. What about this? This is cos x upon sine x. In the numerator you have cos x, and is this equal to the RHS? Yes. And this is what you wanted to prove. So this is complete proof using this method 1. A slightly remodeled question. But then if you want to use, if you want to solve this directly using this. So what we'll do is we'll simplify the LHS first and we'll simplify the RHS in bit, and let's see where does that take us. So method 2 looks something like this. We are talking about method 2 over here of handling this question. Let's simplify the LHS. LHS. Yes, what does LHS look like? LHS has a cot 4x and these terms over here. Sine 5x plus sine 3x. Now this cot 4x, you cannot do anything with this cot 4x. This will remain as it is. At max, we can write it as cos 4x upon sine 4x for now. Okay. What about the sine 5x plus sine 3x? This can be simplified using an identity of converting sum or difference into product. We know that identity. Let's use that identity. Since sine c plus sine d. This looks like sine c plus sine d. Yes. Sine c plus sine d is equal to 2 sine c plus d by 2 cos c minus d by 2. Let's use that. Yes. This is the identity. So which gives me LHS will be equal to what? The cot 4x will remain as it is. Yes. What about this? This is sine 5x plus sine 3x, which is similar to sine c plus sine d. This will convert to 2 times sine of c plus d by 2. Sine 5x plus 3x by 2, that is sine 8x by 2. Cos of 5x minus 3x by 2, which is cos of 2x by 2. Okay, this is what I get, the bracket. Now all of these terms are in multiplication. Can you observe that? Yes. This term in the middle will be converted to sine 4x. This is cos x, which is pretty simple. Okay. And what else? This cot 4x can be written as cos 4x upon sine 4x now. This will be cos 4x over sine 4x. And the other terms are simple. The other terms are sine 4x and cos x. Can you observe that the sine 4x will get cancelled from here and here, and what you will be left with is 2 cos 4x times cos x. This is the simplified version of LHS. Now what about the simplified version of RHS? Can we also simplify the RHS in a similar manner? Yes, we can simplify the RHS. Let's write the RHS first. In the RHS you have a cot x outside and you have sine 5x minus sine 3x in the bracket. Okay. Now cot x at max we can write it as cos x upon sine x, but that's not required now. What is more useful is to simplify this sine 5x minus sine 3x. Now how do we simplify sine 5x minus sine 3x? That can be simplified using transformation identities, transformation of difference of two signs in terms of product. Okay, how do we do that? There's a result. Sine c minus sine d is equal to, let's see, since sine C minus sine D is equal to, we have a result similar to this, right? Sine C minus sine D is equal to 2 cos C plus D by 2 sine C minus D by 2. Similar to this. It's 2 cos a very useful result. A very useful result? Yes. You should remember this result by heart. And let's use this result now. In the LHS you have, in the RHS you have cot x. Let cot x remain as it is. What is there in the bracket? Let's take a look at this bracket. This is sine 5x minus sine 3x, which looks like this. It can be written as 2 sine 5x plus 3x by 2, which is 2 sine 5x plus 3x by 2 is actually 8x by 2 in the bracket. The second term is cos of 5x minus 3x by 2. That would be cos of 2x by 2. Right, that's what we have. Now, this cot x can be written as, what can this cot x be written as? This can be written as cos x over sin x. What else do you have in the bracket? You have 2 times sin 8x by 2, which is actually sin 4x. Cos 2x by 2, which is cos x. So this is sin 4x. This is cos x. Just a minute. Did we make any mistake? Yes. This was actually cos over here, right? Okay, let's not make that mistake. This was a cos over here. This was a sine over here. Let's keep that in mind. This was a cos over here. This was sine over here. This is cos of 4x and this is sine of x. Yeah. Now you can observe that these sine x are getting cancelled and what remains is 2 cos 4x times cos x. Now if this is statement 1, if this here is statement 1 and this here is statement 2, so using 1 and 2 you can observe that LHS is equal to the RHS. Using 1 and 2 we can say 1 and 2 combined imply that LHS is equal to RHS, and that's the complete proof for this question over here using this method, as you can clearly observe. Is it all? Yes, that's all in this question. Let's solve this question. 16th, cos 9x minus cos 5x over sin 17x minus sin 3x is equal to something. How do we prove this one? So what we'll do is we'll begin with the LHS. LHS looks pretty complicated. It can be simplified in terms of this maybe by using somewhat difference transformation formula of converting somewhat difference into products. Now what do we have over here is cos 9x minus cos 5x, which looks similar to cos C minus cos D, and sin 17x minus sin 3x, which looks something similar to sin C minus sin D. Remember those formulae and let's use those formulae over here. We have cos C minus cos D first. Now cos C minus cos D is equal to minus 2 sin C plus D by 2 sin C minus D by 2. What else? Sin C minus sin D will be required in the denominator. This is equal to what? This is 2 cos C plus D by 2 sin C minus D by 2. This is what you'll have, right? If you know these two formulae, then you can simplify the question very easily and solve this, right? Once you are aware of these, let's talk about the solution. Excuse me. In the LHS, you have cos 9x minus cos 5x, okay, in the numerator. And in the denominator, you have sin 17x minus sin 3x. Okay, let's note the question from the LHS. In the numerator, we can apply cos C minus cos D. What is that? Cos 9x minus cos 5x will become minus 2 sin 9 plus 5, that is 9x plus 5x by 2, minus 2 sin 9x plus 5x is 14x by 2. Sine 9x minus 5x, which is 4x by 2. This is something which you'll get in the numerator. What about the denominator? In the denominator you have sine 17x minus sine 3x. This is sine c minus sine d. Sine c minus sine d is 2 cos c plus d by 2. 2 cos c plus d by 2. 17 plus 3 is 20x by 2. Sine c minus d by 2. 17 minus 3 is 14x by 2. And after reaching this stage, please observe carefully that sine of 14x by 2, sine of 14x by 2 are same, will get cancelled. 2 and 2 will get cancelled. What will remain is minus over here. Okay. What else? In the numerator you have sine 2x. And in the denominator you have sine of 10x. Sorry, cos of 10x. It's cos 10x. And observe carefully, is this the RHS? Yes. That's the complete proof. That's a complete proof. That's all? Yes, that's all. Let's solve this question given over here. How do we approach this question? Sine 5x plus sine 3x over cos 5x plus cos 3x. Now for solving this, we'll use transformation results. Transformation of sum into product. Sine c plus sine d and cos c plus cos d. What are the results that we require? Let's write them down. This is one of the identities. The other is, what is sine c plus sine d equal to? Sine c plus sine d is equal to 2 cos c plus d by 2, sorry, 2 sine c plus d by 2. This is a plus over here, right? Sine will come first. 2 sine c plus d by 2 cos c minus d by 2. In case of cos, since you have a cos c plus cos d, what you'll get is 2 cos c plus d by 2 cos of c minus d by 2. That's what you have, right? That's what will be required. So, after you have this thing clear, let's try to simplify the LHS and maybe get the RHS after that, right? Let's take a look at the LHS. LHS is sine 5x plus sine 3x in the numerator. And cos 5x plus cos 3x in the denominator. Numerator is similar to sine c plus sine d. That will convert to 2 sine c plus d by 2. So you get 2 sine c plus d is 5x plus 3x 8x by 2. Cos 5x minus 3x by 2. In the denominator you have cos 5x plus cos 3x, which will be 2 cos 5x plus 3x, that is 8x by 2, times cos of 5x minus 3x, which is cos of 2x by 2. Do you observe that cos 2x by 2, cos 2x by 2 will get cancelled, 2 and 2 will get cancelled. In the numerator you have sine 8x by 2, which is sine 4x. Denominator has cos 8x by 2, which is cos 4x. So sine 4x, this is cos 4x, which will be equal to what? Sine theta upon cos theta is nothing but tan this, tan 4x. And yes, this is my RHS. That is the complete proof of this question using these identities over here. Memorize these identities if you have not memorized them yet. That is all in this question. Let's try to see this question next. How do we approach this question over here? Prove the following. 18th. Say sin x minus sin y over cos x plus cos y is equal to this. Tan of x minus y by 2. Now how do we obtain this? You can clearly observe that sin x minus sin y has to be converted in terms of product. Okay, using sin c minus sin d results, and cos x plus cos y has to be converted once again in terms of product using identity. Okay, so LHS, can I use the identity? Yes. What do I have over here is sin x minus sin y over cos x plus cos y. Since directly angles are given over here, x and y, so I'll use the formula over here directly. Instead of writing the formula separately, I'll directly use the formula over here. This is sin x minus sin y, which will be 2 cos x plus y by 2 sin x minus y by 2, right? Cos will come first. This is what it will convert to. What about cos x plus cos y? Cos x plus cos y will be 2 cos x plus y by 2 cos x minus y by 2. Now at this stage, you will observe that a few terms get cancelled. Cos x plus y by 2 get cancelled. 2 and 2 will get cancelled. And what you will get is this. As you may observe, the angles are same, x minus y by 2. This is sine something, cos that same thing. This is sine theta upon cos theta, which is actually tan theta. Instead of theta, you have a x minus y by 2. And yes, this is equal to my RHS. Simple result, simple solution. That is all in this question. Let's try to solve this question next. What does the question say? 19th. Sin x plus sin 3x over cos x plus cos 3x is equal to tan 2x. Now, how do we handle this question? Let's take a look at this. In the LHS, the numerator has sum of two sine terms, right? And we can simplify those by converting them in terms of product, writing them in terms of product, right? So, we have sin x plus, and in the denominator you have cos x plus cos 3x, and we'll use two important identities of transforming sum of these two, sin c plus sin d in terms of product and cos c plus cos d in terms of product. Let's write the formula first. Sin c plus sin d is equal to what? This is equal to 2 sin c plus d by 2 cos c minus d by 2. What about cos c plus cos d? This is equal to 2 cos c plus d by 2 cos c minus d by 2. Okay, let's use these two identities, these two transformation formulae to simplify this. Sin c plus sin d will be 2 cos c plus d by 2. 2 cos c plus d, as you can observe, is x plus 3x, which is 4x by 2. This is 2 sine, by the way. This is 2 sine this, and the next term would be cos c minus d by 2. C is x, d is 3x, x minus 3x would be minus 2x by 2. This is what you get. Okay. What next? In the denominator, you'll have cos x plus cos 3x, which can be converted by using that formula into 2 cos x plus 3x by 2, which is 2 cos 4x by 2 times cos of x minus 3x by 2. This is what you get, right? And observe carefully that this and this are exactly same. 2 and 2 are also same. What remains is this. Sin 4x by 2, which is sin 2x, cos 4x by 2, which is again cos 2x. This is 4x by 2 is actually 2x over here in the numerator. This is sin 2x. In the denominator as well, you have cos 2x. Now, sin 2x over cos 2x is equal to tan 2x. And yes, this is my RHS. That's the proof for this question. Let's try to solve this question. Question says sin x minus sin 3x over sin square x minus cos square x is equal to 2 sin x. How do we approach this? Observe, in the numerator you have sin c minus sin d form. Okay, let's recall the identity of sin c minus sin d. Sin c minus sin d will be equal to 2 cos c plus d by 2 sin c minus d by 2. What about the denominator? You may observe in the denominator you have a sine square x minus cos square x. Okay, we remember one result related to cos 2a. If you may remember, cos 2a is equal to something. What is that? This is equal to cos square a minus sine square a. And if you remember these two identities, you can easily solve this question. Let's solve. LHS is equal to what? Let's write the LHS first. In the numerator you have sin x minus sin 3x. In the denominator you have sin square x minus cos square x. Okay. I want to apply the results of sin c minus sin d and sin square x minus cos square x simultaneously. Let's use that result. In the numerator you have sin c minus sin d, which will be 2 cos c plus d by 2. 2 cos c plus d is x plus 3x by 2, which is 4x by 2. Okay. 2 cos c plus d by 2, and then you have sine of c minus d by 2. C minus d is x minus 3x, which is minus 2x whole divided by 2. In the denominator, what do you have? You have sin square x minus cos square x. Now this is nothing but the negative of this right hand side, right? So what you get is this is equal to minus of cos 2 times x. This is what you get. Minus of cos 2x, right? Double the angle. Okay. And what will this convert into? Let's take a look at this. This is 2 cos 2x. Okay. What is this? This here is sine of minus x. Sine of minus x will be equal to minus sine x. In the denominator you have minus cos 2x. Okay. You can observe that cos 2x gets cancelled. Even the minus sign will get cancelled, and what you get is 2 sine x. Is that okay? That's okay. Very simple. Yes, very simple to solve using this. That's all in this question. Let's try to see the approach of this question. Prove the following. 21. How do we approach this question? In the LHS you have pretty complicated expressions. Yes, you have angles 4x, 3x and 2x in the numerator. You have similar angles 4x, 3x and 2x again in the denominator. Okay. So the idea that I have in my mind is to simply use transformation formula, use any two angles and convert them into the product. Okay. So I have cos c plus cos d. I look at cos c plus cos d in the numerator. What is cos c plus cos d equal to? I'll combine any two angles, right? What is cos c plus cos d equal to? That is equal to 2 cos c plus d by 2 sin c minus d by 2. What about sin c plus sin d? Sin c plus sin d will be required in the denominator. This is equal to 2 sin c plus d by 2 cos c minus d by 2. Cos c plus cos d would have a cos over here, not a sin over here. This is cos c plus d by 2, right? Let's write the formula properly. That's not the correct formula. This is 2 cos c plus d by 2 cos of c minus d by 2. Sin c plus sin d is 2 sin c plus d by 2 cos of c minus d by 2. Once we have okay with this, let's begin with the LHS. What does the LHS say? LHS says that can we club together any two particular angles? Yeah. So let's take the two extremes and club them together. That's the easiest step, right? Let's club the two extremes. What you have is cos 4x plus cos 2x. Okay, and a cos 3x. What about the denominator? Similarly, we'll club together two extreme angles. Sin 4x, sin 2x will come together, and sin 3x will remain separate, right? Sin 4x plus sin 2x and sin 3x can be written separately, right? Remember, keep in mind that you have to reach this angle 3x finally. Okay. How do we reach that? Please observe. Cos c plus cos d. Cos 4x plus cos 2x will be 2 cos 4x plus 2x, that is 6x by 2. Cos of 4x minus 2x by 2, which is cos of 2x by 2. So this is 2 cos 6x by 2 cos of 2x by 2 plus cos 3x is already there. What do you have in the denominator? You have sin 4x plus sin 2x. Sin c plus sin d is 2 sin c plus d by 2 cos of c minus d by 2. Sin 6x plus sine 2x will be equal to 2 sine 6x plus 2x 8x by 2. Sorry, 4x plus 2x 8x by 2. 2 sine 6x by 2. And along with that you have sine 4x, sorry, cos 4x minus 2x, which is cos of 2x by 2. Okay, these are the angles that you have over here, plus there's another term in the denominator which is sine 3x. Let it remain as it is. What does the numerator simplify into further? Please observe, in the numerator you have 2 cos 3x cos x now. Plus there is another cos 3x. Okay, what about the denominator? You have sine 3x and cos x again. Plus this is sine 3x. Okay, what else? Once you have solved this much, let's continue further. This implies LHS. Okay, let's keep this separate. LHS will be further equal to what? Can you observe that cos 3x and cos 3x are common in these terms, and let's take that out. Cos 3x will come out common in the numerator. What remains is 2 cos x from the first term. What about this term? If you take out cos 3x, what will remain? Nothing, basically 1. Right? This is in product, right? So 1 will remain over here. Similarly, sine 3x can come out common over here. And this 2 cos x plus 1 remains over here. Okay, now I see an interesting thing. I can cancel these 2 cos x plus 1 and I get as cos x cos 3x over sine 3x. Cos 3x over sine 3x is equal to cot 3x. Is equal to cot 3x, and that is what was required. That is all for this question. Let's solve this question over here. What does the question say? We have a very complicated expression in the LHS, and in the RHS we have a pretty simple expression. Okay, makes things quite interesting for that matter. What do we have? Cot x, cot 2x, minus cot 2x, cot 3x, minus cot 3x into cot x is equal to 1. Now, very interesting approach can be used over here, and let's talk about this approach. But before I discuss this question, I'll discuss another question. Before I actually go about discussing this question, I would like to talk about one more question. What is that? Tan 3x minus tan 2x minus tan x is equal to tan 3x into tan 2x into tan x. Now, some of you may have encountered and solved this question, right? If you have not solved this question, let me discuss the idea behind this and this are exactly same. Okay, we'll have to begin with something obscure, something which is not related, seems not related, but which is actually related to this required result over here. For solving this, do we actually begin with this LHS? No, we cannot apply transformation properties in this. Transformation of sum or difference in terms of product. Can we apply that? No. Transformation results are there for sine and cosine, but they're not there for tan and cot. So we have something else in mind in that case, right? What is that? Do you observe that I can write tan 3x as nothing but tan 2x plus x? What's so special in this? There's nothing special in this, but after I write this, I can maybe apply the formula of tan a plus b over here, right? Will that be possible? Yes, that is very much possible. So, since tan 3x equal to this implies tan 3x will be further equal to tan of a plus b. The formula says tan a plus tan b over 1 minus tan a tan b. Tan a plus tan b over 1 minus tan a times tan b. What next? Let's cross multiply this. Okay, let's bring this denominator over here. This will come in the product, and tan 3x times 1 minus, this is the denominator over here. What about the RHS? RHS will be tan 2x plus tan x. This is what you have in the RHS. Is that okay? Yes. Once you're through with this, what will happen is tan 3x times 1 would be tan 3x minus. This is tan 2x tan x times tan 3x would be which is equal to tan 2x plus tan x. And can you observe that these two terms are in addition, we can bring them over here, they will convert to this, and this tan 3x into tan 2x into tan x, which is in the negative, will go over there and it will become this. So from here I'll reach this stage. From here I'll reach this stage. Is that okay? Yes. This here is one thing. Right, we started from here and finally reached this stage. Now once I have proved this much, can I continue from here? You want to continue from here? You were saying that this is something else. This is not something else. Actually, we can continue from here to get this result. Think for a minute and then see. See the magic. What I'll do is, once I've reached this stage, what I'll do is, let me get rid of this. We have already used this. We have arrived at this stage. You're starting from tan 3x. What I have is a result in terms of tan, and now I can apply simple transformation using conversion of tan x into cot x, tan 2x in terms of cot 2x, and tan 3x in terms of cot 3x. Let's use that result. Tan 3x can be done as 1 upon cot 3x minus this is tan 2x, which can be done as cot 2x. Tan x can be done as cot x. This is further equal to 1 upon cot 3x, 1 upon cot 2x, 1 upon cot x. So this is 1 upon cot 3x, cot 2x, cot x in the denominator. Okay, what next? There's something in the denominator over here. I want to multiply this thing throughout over here. That is, I want to multiply throughout by cot x, cot 2x, cot 3x. The product of cot x, cot 2x and cot 3x. Let's multiply that together. Multiplying by cot x, this product. What does that give me? In the LHS, what you have is, on multiplying this by the first term, what you will get is cot 3x will get cancelled, and what remains is cot x times cot 2x. One upon cot 2x multiplied by this will be cot x times cot 3x only. This 1 upon cot x when multiplied by this will give me cot 2x times cot 3x. What about the RHS? In the RHS, if you multiply cot x, cot 2x, cot 3x, this is the same as denominator. What you get is simply the numerator, which is 1. And do you observe something interesting? What you have over here is cot x, cot 2x, okay. Cot 2x, cot 3x with a minus, cot 2x, cot 3x with a minus, and cot 3x, cot x with a minus, and that is equal to 1. Yes, this is what we obtain, and is that done? Yes, that's done. This is the complete proof for this one. We started with something which was quite unrelated to any of these, but then with the help of that, yes, we have proved this particular result over here. That's all? Yes. Oh, but if this looks pretty complicated, then do we have another approach for this? We started with something obscure, right? Some people may have a difficulty in this. Oh, how do we know that we start from it? There are very few questions, by the way, which begin in this manner. But then if you want a more direct approach, let's try to look at it in another way. But for that also I'll require one more formula, right, which you generally don't memorize. Let's see the other approach, method 2 of handling this question. Let's begin with the LHS first. Okay, what do we have in the LHS is this cot x times cot 2x. Okay. And actually cot 3x is the complicated term. Let's take out this cot 3x common from these terms. What remains is cot 2x plus cot x minus cot 3x. This becomes cot 2x plus cot x. This is what you have. Okay. Now let us recall the formula for do you recall the formula for cot a plus b? You should. What is this equal to? This is cot a cot b minus 1 over cot b plus cot a. If you remember this formula, your life would be pretty easier for this question, right? What do we have in the LHS? LHS is cot x times cot 2x. I want to write this cot 3x as cot of 2x plus x. This 3x can be done as 2x plus x, right? And then I want to apply that formula, okay? As it is, minus this is cot of times. Okay, this is what we have. And let's apply cot 2x plus x. What does that give me? Cot x is okay. Minus, if you remember that formula, things will become very easy. What you have over here is cot a plus b, which is cot a cot b minus 1. This is cot 2x cot x minus 1 over cot b plus cot a, which is cot 2x plus x, cot x plus cot 2x in the denominator. This is cot 2x plus cot x in another bracket over here. So again in multiplication, okay, I see this bracket, I see this bracket there. In multiplication, these terms will get cancelled, right? The same, okay. And what else remains is cot x times cot 2x minus, this is cot 2x times cot x, and minus minus becomes plus, this becomes plus 1, and you observe that these two terms get cancelled, and what you get is a plus 1, which is equal to the RHS. Oh, this looks pretty simple. Yes, this looks pretty simple and is pretty simple if you remember this. Okay, cot of a plus b, this is pretty simple, right? That's all in this question. Some people would enjoy this approach, and other obviously adventurous fellows may enjoy the first method. But then these are both the methods. This is a simpler version. Yes, pretty simple if you remember cot of a plus b. That's all for this question over here. Let's take a look at this question over here. Tan 4x equals 4 tan x times 1 minus tan 2x. No, this is not tan 2x. This is actually tan square x. Okay. And 1 minus 6. Again, this is tan square x plus tan power 4x. This is what we have. So how do we approach this question? Okay, this looks pretty complicated. So should we begin with the RHS and convert in terms of 4x? That looks simple, but is it actually simple? No, tan 4x is actually 4 times this angle, and we'll have to club them together to get that 4x. Alternatively, when you are given a higher angle, and simplification is relatively easy because you know multiple and submultiple angle formulae. That is, you know formula for tan 2x, and you can apply that formula on tan 4x to convert tan 4x in terms of tan 2x. Yes. How do we do that? The formula, recall the formula. Tan 2a is equal to what? Tan 2a is 2 tan a upon 1 minus tan square a. I can use this formula on tan 4x and convert in terms of half angle, that is tan 2x. But you have a tan x over there. Everywhere you have tan x. I can apply that same formula on tan 2x and convert that in terms of tan x after that. Yes, I can do that and get a result. This. So what do we have? We have to prove, let me write the question. To prove tan 4x is equal to 4 tan x 1 minus tan square x, that is tan square x over 1 minus 6 tan square x plus tan power 4x in the denominator. This is what you have. And I can begin with the LHS. Let's begin with the LHS over here. LHS, though looks simple, but it is misleading. It is tan 4x. Right? Tan 4x and compared to tan x is complicated. Right? So tan 4x can be written as tan of twice 2x. Right? This is what you have. 2 times 2x. This is tan of 2a. I want to apply the formula of tan 2a, which is 2 tan a upon 1 minus tan square a. This will become 2 tan 2x over 1 minus tan square 2x. Okay, what next? Now I want to apply that formula, same formula again. What do I want to do is, I want to write this tan 2x as 2 tan x upon 1 minus tan square x at both of these places. What you have is 2 times, this is, okay. What about this? 1 minus, this is tan 2x whole square. Okay. So tan 2x whole square. What is tan 2x? This is 2 tan x 1 minus tan square x. This is what you have in the denominator. A pretty complicated looking expression, yes, but we can simplify that. Let's do it. This gives me LHS equals what? The numerator. Let's take a look at the numerator. What is that equal to? This is 4 tan x over 1 minus tan square x in the numerator. What about the denominator? In the denominator you have this square over this square. Can we take the LCM? Yes. Let's take the LCM. So this is 1 minus tan square x whole square. This is 1. On taking the LCM, this will become 1 minus tan square x whole square will come over here minus this square. What is this? 2 tan x whole square. That is 4 tan square x. This is what it will convert into. What else? Next step. Next step is to simplify this further. This is numerator, denominator. Numerator divided by denominator can be converted by inverting the denominator and multiplying it. What you have is 4 tan x over, this is 1 minus tan square x. Let's leave it as it is. And let's multiply the remaining thing. What you get is, invert the denominator and multiply it, right? What you have is, the denominator's denominator becomes the numerator, actually comes in the numerator, 1 minus tan square x whole square. And in the denominator you have this expression. What is this? Let's expand the 1 minus tan square x whole square. What you get is 1 plus tan power 4x minus 2 tan square x. And there's a minus 4 tan square x already waiting over here. Okay. Now we seem to have simplified a lot of these things. What you have is a 4 tan x in the numerator. Observe that. This 1 minus tan square x and this 1 minus tan square x whole square. One factor will get cancelled. You will get a 1 minus tan square x in the numerator. What about the denominator? This term is gone. The remaining thing is this. What is this? 1 minus 6 tan square x. Do you observe that? This is 6 tan square x plus this is tan power 4x. This is tan power 4x. And observe carefully, this or this, are they same? Yes, this and this are same. This is equal to the RHS, hence proved. Let's take a look at the complete solution once again. Let's take a look at the question, corrected question first of all. This is tan 4x. There was some typing errors in that. So tan 4x is 4 tan x, 1 minus tan square x over 1 minus 6 tan square x plus tan power 4x. Should we memorize this value? No, there's no need to memorize this value. Just have to solve this. Tan 4x is equal to this. First we use this identity once and then we have to use this identity again. After that we simplify and reach this answer. Let me get aside for a bit so that you can take a look at this. This is all that is to be done over here. Let us take a look at this question. Cos 4x equals this. Now cos 4x can be simplified easily to convert in terms of x. How do we do that? We'll use identities. We'll use formula for cos 2a. What is cos 2a equal to? You need a 1 over there, right? So why not use the result 1 minus 2 sine square a. Cos 2a is also equal to other things. What is that? This is also equal to cos square a minus sine square a. Or this can be done as 2 cos square a minus 1. It can also be written as 1 minus tan square a over 1 plus tan square a. That's another version of this. These are some important versions, right? We should memorize this. Let's simplify cos 4x. In the LHS, you have cos 4x. Cos 4x can be done as cos of 2 times 2x. Yeah, yes. Cos of 2a, that can be done as 1 minus 2 sine square a. 2x. But still, we have only reached 2x, the angle 2x. We want to reach the angle x. And for that, we'll have to think in terms of simplifying sine 2x. What is sine 2a equals to? Sine 2a can be written as 2 sine a times cos a. Sine 2a is equal to 2 sine a cos a. And therefore, 1 minus, this is 2, which is okay. Sine 2x is 2 sine x cos x whole square. Is that okay? Yes. So, this will be equal to 1 minus 2 times 2 square is 8 sine square x cos square x, and this is what you get. Is that okay? Yes. This and this obviously same. So therefore, this is equal to the RHS, and that's the complete proof for this question over here. Take a look at this complete proof over here. Is that all? Yes, that is all for this question. Let's try to solve this question next. 25th says cos 6x equals this huge expression. Oh, how do we solve this cos 6x? So cos 6x can be solved using two identities for that matter, two identities used one by one. So from cos 6x we have to reach x. We have to convert this in terms of cos x. Okay, and there's a simple result of cos 3x first. I remember result of cos 3x. What is cos 3x equals to? Or we can say cos 3 theta or cos 3a is equal to 4 cos cube a minus 3 cos a. Now you may say, sir, cos applying this will only convert 6x into 2x. Okay, so we have another result after that. Since we want the final answer in terms of cos x only, so cos 2a can be further written as 2 cos square a minus 1. This is another result of cos 2a, right? We can use these results one by one. So let's begin with the LHS first. In the LHS we have cos 6x, which can be written as cos of 3 times 2x, right? Cos of 3a, that is what we have. Cos of 3a. Cos of 3a is 4 cos cube 3a. 4 cos cube a minus 3 cos a, which is 4 cos cube 2x minus 3 cos 2x. After this, I can write that cos 2x in terms of cos x, which is cos 2x will be equal to 2 cos square x minus 1. Let's do that. 2 cos square x minus 1 and whole power 3. 3 times 2 cos square x minus 1. This is what you will get. I hope that's clear. Yes, pretty simple. You can see this. Cos 2x will be 2 cos square x minus 1. Cos 2x will be 2 cos square x minus 1, and there's a cube over here. This is what you get. After this, I need to apply a minus b whole cube. And that will make my calculation very easy after that, right? So what we have is 4 is okay. This is a minus b whole cube. The formula for a minus b whole cube is, let me write that formula. A minus b whole cube will be equal to a cube minus 3a square b plus 3ab square minus b cube. Let me write a minus b whole power 3 is a power 3 minus 3a square b plus 3ab square minus b power 3. That's what I will be getting, right? Let's take a look at this. This is a power 3, 2 cos square x power 3. What will that be? 8 cos power 6x. I hope that's okay. 2 power 3 cos square x power 3 will be this. Minus 3 times a square. A square is 2 cos square x whole square, which is 4 cos power 4x. 3a square b. B is simply 1. That's okay. Yes. Plus 3ab square. 3 times 2 cos square x times 1 square. Okay. Minus b cube, that is minus 1 cube. That's what you have over here. This term has been simplified up till now. Okay. This is one bracket. And you have minus 6 cos square x, as you can observe over here. 3 gets multiplied with 2. And minus 3 times minus 1 is plus 3 over here. What else? Let's write the next few steps and get the final result. This gives me LHS will simplify into what? Observe, this 4 is getting multiplied with this complete bracket. Let's do it. 4 times 8 is 32 cos power 6x. Okay, we get a matching term over here. What else? This is 4 times 3 times 4. What is that? 48 times cos power 4x. Okay, this is again matching over there. What is this? 3 times 2, 6 times 4 is 24. 24 times cos square x. And minus 1, this becomes minus 4. What else? This is minus 6 cos square x plus 3 remains. And now they can be clubbed together, added together, and we will get the result. As you can see, this is 32 cos power 6x minus 48 cos power 4x. This is minus 24 plus 6, which is, plus 24 minus 6, which is plus 18 cos square x. Do you see? This is also matching. Minus 4 plus 3 is minus 1. Yes, this is the LHS which has been simplified and we have obtained it equal to RHS. Is that all? That is all for this. So we have used these two results one by one and obtained the required answer, as you can clearly observe behind me. Alright. Is that all? Yes, that is all that we have to do in this question. Let me get aside and you can take a look at the solution. And with this, we come to the conclusion of this exercise 3.3, based on trigonometric functions, chapter number 3 of NCERT class 11th. And if you have enjoyed watching this session with us, please subscribe to this channel of Vyas Edification. Also, like this video. And if you have really enjoyed watching all the solutions, attending the questions and discovering new methods, please share this video with your friends. Till the next session, all the best.